Welcome to this channel. We'll be looking at fundamental theorems of calculus. I'll first give us two of them, and then we'll solve our questions. Then I'll give us another one again. So let's take the first theorem, and that one is what we call the derivative of integrals. What this one is saying is that we have ddx of integral this f of t dt. The condition is that what you have here, the variable here must be the same thing. This is x, this is what? This is x. So it is equal to what? You substitute this one into this place, and that would be what? F of x. And that finish that. I'm going to play with questions on this. But if this is now becoming maybe s squared, s cubed, then you have to use, we'll talk about that one later. And again, what you have here must be a positive integers. Number two is the definite integral. If you have the lower limits, the upper limits of f of x is going to be what? This minus what? Minus this. I'm going to explain this one with example. What this one means is that you get the what? Integral of this function. This is the x. Okay. Once you get the integral of this function, then you begin to what? Put the upper limits and then minus what? The lower limits. So without much ado, let's go to questions. This is what we have. But don't forget, this one is what we call the definite integral. And this one is called derivative of what? Of integral. So let's look at this, what we have here. Evaluate definite integrals. So the first one is going to be this one. Integrate this. That will be 60x. This power 1 plus 1. That's 2 over 2. Then minus 6. This is power 2 plus 1. That's x to power 3 over 3. Then don't forget your upper limits and the lower limits. So this one will give you what? This will give you 30 x squared minus 2x cubed. Okay, indicate your upper and the lower limit. Then you can begin to substitute now, and that will be 30 times, this will be 10 squared minus 2 times 10 to power 3, and then minus, do your lower limits. All this will be 0 minus 0. Okay, so we have 100 here times this. That's this minus this one will be what? 1000 times 2. That's 2000. So your answer is what? This one is 1000. Yeah, the second one, you can take this 3 outside. So you have this sin x dx 2 pi 0. Integral of sine is minus cos the function. Okay, indicate your upper and your what? Your lower limits. Don't forget this one. That's minus 3. Okay, so you now have minus 3. Do your upper. That's a cos 2 pi. So you begin to substitute your upper into that variable minus. You repeat the process again. Cos the lower. That's what. That's 0. This is the upper limit. We've done that. This is the lower limits. That's what we have here. Okay. Cos 0, I think is that's 1. Cos 2 pi, that's 1. So 1 minus 1. So this will give you what? This will give you 0. So that's that on this question. Simplify the following. If you check what we have here, we're having derivatives of integrals. Okay, this is just derivative of integrals, and I've given the formula for that. Okay, it's just the applications of the formula. It's very simple. We go straight to the solution. The observation, the first observation is this: the variable here, okay, and here must be the same thing. Okay, once they are the same, it's just direct substitution. So the first one is going to be equal to sine square. Then you substitute your x for t. That's x, and that finished your solution. That's the first one. The second one, the second one is just a little illustration we are going to make here. We expect the variable here to be on the top, but the variable is at the bottom, is at the lower limit. Okay, so we are going to force it to obey the rules of derivatives of integrals. Okay, and that will be equal to this one is going to be equal to we are going to first of all solve this one. So this one will be equal to minus integral of, then you can now swap the lower and the upper limit. So once you've done that, that's your question, and that will give you what? Minus what? Minus square root of what? S squared plus 1. Just make your substitutions. And when you see your t, you put your x there. And that's that. Since this one, we don't put plus c in this case. The definite integral, we don't put we don't put plot c. The derivative of integral, we don't put plot c. In the c part, so what will happen is very simple. You do your substitution. That will be equal to what? Cos. Your t is what? You're substituting this one. That will be x2 power 2, and then times derivative of this. Okay. So for the lower limits, no substitution. You don't need to do that. You don't need to waste your time. Okay. Except it's also a function. Probably is a function of something. So we're going to get to the case where you're going to substitute for the lower limits. Okay. But in this case, no, you don't do that. No need for that. Okay. And that will give you cos. This will be x4. If you differentiate this one, that will be 2x. And that finished that question. Yeah, for this, we have this one, this following question. We have this following question, simplify the following expression. And we have these two questions. Without wasting time, derivative of integral, very simple. Do your substitutions. But in this case now, this one and this one, they're not the same thing. So let's do the substitutions. Anywhere you see t, you put your what? Cos x there. And that will be cos x to power what? To power 4 plus what? Plus 6. Okay, then you now do the what? Do the ddx of your what? Of this place of cos x. Okay, and that will be equal to derivative of this one is what? Is minus sine x. This will be what? Cos to power 4 and then plus 6, and that ends that one. For the second one, the first thing we are going to do that what we have there, the variable here and the variable here is not the same. That variable is at the bottom, so we're going to make it to obey the law. This will be equal to minus into times integral of change the limits, change that limit, and by the time you do that, minus will come in, and then that's what? E to power t2 dt. And after that, you can do your direct substitutions. So don't forget your dx, okay? And that will be equal to minus x to power 2. And that's that on that case.